David Vizard here, and you, my friends, are watching PowerTec 10. In this edition of PowerTec 10, we're going to have a look at one of Ford's engines, which was not, how shall I say, immediately accepted as a performance engine. That's the 2.3 Lima 4-cylinder engine. That's the one that succeeded the 2-litre engine, single overhead cam 2-litre engine. Now, it had some weird intake ports. What they did was they made a slightly more expensive cylinder head so that they could save a slight amount of money on the intake manifold. So all of the ports point towards an intake manifold which has a single 2-barrel carb on it. So we have ports like this and ports like that. Now, it did kind of take off slightly, but the interest in this engine seems to keep on going on and going on and going on. And as a result, today, after what, 30 years after its, more than that, after its introduction, it has become quite a powerhouse. There is stuff out there to do all kinds of things with it, even bore and stroke it out to 3 litres. But I'm going to look at the turbocharged side of things here. One of my fellow PowerTec 10 assistants when it comes to dyno testing has got one, and he's rebuilding the engine and is looking for a bit more power. Well, actually quite a lot more power. It makes over 700 at the wheels now, which is a pretty good achievement, and as you may guess, it's not a stock motor. The head we're going to look at is not the original iron head, it's the Esslinger aluminum head, which comes from Esslinger or from Ford in CNC form. So we're starting off with a head that's already got CNC work on it. So let's dive into it here and see what we're faced with. As we get this cylinder head, we can see that there's a lot of work already done on the ports and the chamber. Now, I have to say the chamber on it is not of a very good design. With all the best intentions, it lacks any science going into it. It's more a question of we've used these techniques before, simple techniques at that, and we'll do it again, without apparently any rhyme nor reason. So instead of starting with the ports, I'm going to start with the combustion chambers. So let's have at it. Well, it's time to do some cylinder head chamber work here on our Turbo 2.3. I've already leveled it up, got it really level for the machining of the chamber around here, but here's what I want to show you first. See this step here? The last person to cut the seats on this did a lousy job of it. So nevertheless, this engine has made 733 horsepower at the wheels as a street driver, so it's still pretty good, but we are going to do much better. We're probably, by the time I finish this chamber, we'll probably be 50 horsepower up on the same boost. Right, so first thing to do, mark out the chamber. Here's the head marked out. The next thing I've got to do here is set this cutter up, this cutter here, so that it machines the wall here. Let me indicate that with the, so it indicates this, the vertical part of the wall here right on that line. Then it goes down and it cuts this form here. But that's so you could see, basically this is a 20-degree angle here. Well, here's our cut nearly done. just got to machine out that step, so I have to go down a little further yet. Okay, let's see where we've got to here. Just pull this out, and the spring, so that you can get a better look at it. Well, you can see how much has come out, right? It's a bunch. All of that metal that has been taken out was shrouding that exhaust valve at low lift. Remember, it's not flow, it's area. And we've come up here to about 200 thousandths where the area stops being the important factor and the flow does, because it drops to about subsonic, about this much lift. Well, we are now at the stage when we have all the chambers around the seats machined, intake and exhaust. Now you can see just how much I had to take out to de-shroud the exhaust. Our next move is to cut this area here and remove the shrouding here. Now when the piston comes up to the top of the stroke here, it is going to, this chamber shape is not right. It's going to shoot the exhaust gases straight over the top of the valve. Now the chamber's not angled enough for us to cut this to an optimum shape, so what we have to do, let me turn this around, what we have to do here is relieve this a certain amount, and I'll mark it out and I'll show you what that is. Then when the head's skimmed, we have to put a generous radius on this here, so that there's an opportunity for the gases to come up and make it round the corner. Now this is quite a delicate shape, because it's important that it goes out that way, because this is the direction of flow out of the exhaust port. We want to maintain as much energy in the exhaust as possible, and this is one way of doing it, so that we drive the turbo, not have flow resistance here. So that's point number 2. I've got to mark this out, and I'll show you what that is. First, we have a valve which we put in level with the top of the chamber. Now you'll notice that it's got a center dot in it here. Then with the calipers set at 1.3 inches, we scribe out the chamber like so. As you can see, not too much to come out of it initially, but nonetheless that's our starting point. The area we're most concerned with here is this here, right? We tend to have a swirl going around this way. We need it to be able to get down underneath that valve. So we mark all those out. I've put a protector valve in here to protect the seat. Give the chamber a quick shot of WD-40, as that has kerosene in it and that acts as a very good cutting agent. The cutter I've selected is a 1/2 inch ball wheel, and the reason I've done that is because I am going to undercut it just here, just to maximize the area available, but I've got to come back to the gasket line, so that's what I'm going to do. So here we go. Okay, we have the deshrouding on this part of the chamber done. Now watch, let me push that valve in, I'll pull this up so that the valve is open by the diameter of the ball, and you'll see that it will pull, let's just turn it there, it will pull right the way through, which means that the area here as the valve comes up is maximized, and that's our goal. Now I'm going to do the rest of the chamber, and then I'm going to address this bit here. The plateau scavenging on these heads is not very good. That's because the chamber is too deep this side, right? So we've got to do with a makeshift job, and I'll show you how we do that when I've done the rest of the chamber. And here we have all 4 chambers done on the downside here. Not much to come off the exhaust. It's just a question of blending the seat in to the chamber just here. The amount that comes off here is nothing more than to clean the blue off. Right, let's turn this dude over and start on the other side. Let me bring your attention to this line here. That is the radius that we scribed over here to give us 0 shrouding all the way across this area. Now you would think that we want the same over here. Well, you would be thinking incorrectly. We do not want any more out of the chamber than is there already. Why? Because there's not as much flow down here. So we don't need to de-shroud it as much because not as much exhaust is going out. That's point 1. Secondly, what we want is for the exhaust gases on this side to go over the top of the valve. Right? Since not much is flowing there, let's not have a jet of exhaust finding its way down here and having too much flow this side, because the port won't handle it. Right? That's got to be the short side turn there, and it needs no more exhaust out there than it can accommodate when we're in the flow regime. We will, when we're in the area regime, that's up to about 200 thousandths, have the port, this part of the port, area ruled as I call it. Now, so what I'm going to do here is, let me take this valve out and show you. I'm going to area rule it with, I'm going to area rule all this round here with this ball, but I am not going to go over that line there. Right, so let's tackle that. Well, here's all the spark plug side of the exhaust done. Note how much is left for the completely geometric shrouded valve at the line there to what we've actually cut. Now, the ball pulls through very capably, and it's area ruled from about here down. Next to do is this bit here. Not much to do to that. Here I am just about finished roughing out the long side spark plug turn here. Now I want you to notice this here. It will pull through right round to there, almost 90 degrees. Now the important bit here is getting this bit unshrouded here. The reason is we want more flow on this side of the valve. It's very dead. This will help promote some swirl. This cylinder has very poor swirl, so this is quite important. You will see the rest of this is not touched. Now, I just want to make a point here. Spark plug is far from in the ideal place, and there's certain things we have to do to the chamber to try and compensate for this, because this spark plug position does not favor any anti-detonation tendencies. If you can hear me, now's the time to do a provisional polish on the chambers. I say provisional because when we polish it, it shows the shape and the contours up better, so it's easier to see what you're doing. Well, here we are with the chambers all provisionally polished. You'll see why that's so. But I can see that after this provisional polish, there's a few small discrepancies and waviness, but the next polish operation will fix that. What I'm showing here is the finished chamber. Not significantly different in shape from the one I've just shown you, but you can see the curves here much better. Notice this is undercut here, and you can't quite see it, but it's undercut up to about here, so that at low lift we can get some airflow into here. We don't want to come back too far with it because it will spoil the high lift flow. Now let's look at this with the valves in, because there's some pertinent stuff there. I've just put the seat protector valves in, which I should say that on the underside of them, they are the finished shape for the valves that we're going to use. Now here I've lifted this valve, the exhaust valve, to about the height where the supersonic flow will finish. And you will see that we've got good clearance, area clearance all the way around. Right, we can even get the deal out there. So the shrouding is only very marginal. I did do some quick estimates on that, and this at this valve lift here, this valve is 96% unshrouded in terms of area, which is all we care about for the first about 200 thousandths lift. As it happens, we can also demonstrate the intake clearance here. Right, you'll see that it's up at this lift, it's not shrouded until we get to around there. Now this is important. If you can keep the valve unshrouded and get your turbo set up so that it has 2 or 3 pounds more boost than it does back pressure, this scavenges the chamber very well, and in fact the horsepower per pound of boost actually goes up. If you can get 5 pounds of boost more than back pressure, and it is possible, then you are on a winning streak, because that will give very good scavenging and decrease the pollution of the remaining charge or the new incoming charge with exhaust. That's the key to making 1,000 horsepower per litre. When cutting the port bowl, you need to focus on the cylinder wall side. This helps not only with flow, but also with swirl. Where I'm indicating here is the main part. Now, air coming in on this side of the port here will swirl round as I'm indicating. This swirling action will also cool the spark plug better. Well, there's the work done with the 1/2-inch ball. You'll notice there's a big patch at the back still. Now let's move across to this one here. I've cut in behind the guide there on the guide boss with a 1/4 inch wheel. I'm also going to shorten the guide by about a 1/16 of an inch. This is the port that aims in toward the center of the cylinder. What happens is it's too far over to generate swirl. It almost always just goes charging across and runs into the cylinder wall. Now what we've got to do is encourage more flow on this side of the port. So, as it happened, this flow over there is made worse by the fact that this face here actually comes out more like this and round. So I've taken enough off here to allow air to have a straighter route in and up this side. This part of the port here needs to be widened considerably. Not the top, just the bottom here. This means that this wall here will be slightly cocked over at an angle like that. And you need to lower this face here. I haven't finished doing it yet, but that will get done. Just showing you what's there. To get the radius on this side to the maximum possible, I break through into the bolt hole here, then I sleeve it. However, it's not a supercritical point. let's say you just grind that and you can just see it's just breaking through. Well, pull off any bits that might be a problem, and you will find that the bolt will seal it. But you won't get quite as big a radius on here. It'll be about a 1/16 less. The trouble is this is at the critical point. So my last job on this head will be to sleeve this and finish this off. On the second port along from the totally bad one, that's the one with the bolt hole broken through, this is where you need to grind. Along here, most of the air is flowing on this side of the port at the top. So this is the area you work on. Don't take any off here, but slope it down here and focus on this corner. Right, raise the roof there, and I think I had a little bit more to take off there. Right, but you want it to be almost straight in so that the air goes on this side of the port. Right, so let's just clean that one up now and see what that looks like. Hopefully you can get the shape of the port here. I've just sand rolled the bit that I had cuttered earlier on. So let's shine it in from this side as well. Right, should be able to see that. Again, what we're doing here is working on this side of the port so that it favors the swirl coming out. That swirl not only improves combustion, but it also cools the spark plug. Okay, a couple of things to say about the exhaust port. Note the shape of the guide boss I've got here instead of that bulky boxy like thing that's stock. The area of the guide boss here is reduced, so the amount of heat that it absorbs to heat up the guide is reduced. Also, all of the material here is closer to the water jacket, so it gets cooled better. Now, I have shortened the guide itself by about a 1/16 of an inch, maybe a little bit more, but that's going to be okay. The water injection on the engine is going to keep this cool enough under full boost conditions. Now you can probably see what I'm doing here is I'm rounding off this edge so the gases can transfer over and down there easier. And most importantly, right at the last moment when the piston approaches this face and shoots the gases out, instead of it tending to go over the top of the exhaust valve, it'll stand some chance of making it round the corner and out, thus reinforcing the flow at the last part of the exhaust stroke, which is good because that will be a little more impulse for the turbo. All I've got to do now is finish that off. Finishing touches is this. That should give you a good idea of how this is formed. Remember, this is to help the gases go out, and of course that's the direction they're going to go out. So that last oomph just before the end of the exhaust stroke is the crowning glory of a port like this. Well, here's our cylinder head finished. Now, probably looks pretty good at this distance, all nice smooth finishes. Yes. Now, there's kind of a rush to get this cylinder head on the engine here to get to a race meeting. Now, I say it's finished. This is not where I would have finished it here. The next one we do is going to have the full treatment. The chamber and the valve and the ports will all be thermal barriered appropriately. Now the reason for doing this is that at the power level we're at, or we're hopefully at, the head gets considerable heat into it and it can get soft. Result, blows head gaskets. I'll give you an example of how good a coating can be on there. I had a coating done by a company in Denver, not Denver, Colorado, Denver by Charlotte. I'll put the name across the bottom here. We did a before and after test. Now, the before test, the cylinder heads would only make about 8 passes before they virtually were wrecked from excessive heat. When we coated them, they had absolutely no sign of giving in after 40 passes. Now I'm talking about a real high output engine here. We're talking about one that was making 750 horsepower per litre, right? And that's a pretty stout number. Now if there was ever a cylinder head which had to be finessed to get results, this cylinder head is it. A lot of attention went to the form around here for area ruling it, and notice this radius here. I'll zoom in on it so that you can see it. For enhancing the scavenge at TDC, the ports, the seats, everything, every little detail adds up. As a result, on a typical 30-pound boost 2.3, this will give between 70 and 85 horsepower more than it did stock. At 45 pounds boost on a 2.3, it's worth a solid 80 horsepower. If you're using more boost than that, it can be worth up to 100 horsepower plus an extended RPM range. So that's good. Now, how much work did I have in this? Like I said, it's all a question of details. I've got about 60 hours work in this. And if it was going to be powder coated, thermal barrier coated, then just retouching all the seats and things like that after probably makes it another 10 hours work. Not so fast in accomplishing this, but very well worthwhile the results. Anyway, here we are. It's going to go on the flow bench. So there we go. That's the next move. Whilst I was ploughing my way through this cylinder head, one thing that occurred to me is that if you're going to go the whole hog on this, you had really better have some porting experience. Of course, there's going to be a limited number of you capable of just doing a head like this, although I'm sure there'll be some brave souls who might just tackle it anyway and do the best they can. But what I thought I would do here is recommend some sources to get your Lima head ported. The first on the list is, and this is a pretty cool name, right? Steve's Head Shack. Steve is an ex-Cup Car head porter. Don't assume you're going to get a cheap job. You're not. You're going to pay a fair price for highly skilled work. Steve turns out heads that are top-notch. You won't get overcharged, but you will be paying the going rate. As for quality, he has a very good reputation. So I'll put his contact details along the bottom there, telephone number. The next one I want to mention is Beauport in California. I've spoken to Beau on the phone. However, one of the things I'm fairly sure of is that they use a flow bench extensively. There are numerous test results on the internet that have been posted of heads he's done. What I'd like to do there is to mention that basically Beau focuses intensely on the 2.3 Lima engine. That's the way to go. So if you're in the California area, here's his address going underneath. The next company I want to mention is Engineering Motorsports Solutions Inc. This is Jesse Ringley. Now Jesse is a PhD engineer. Started off tweaking cars for himself, and then got so much demand from his friends and associates that ended up being a professional. Currently, he is the fastest EcoBoost Mustang on the face of the planet. I'm kind of excited about getting in touch with Jesse and the rest of the gang there. They are going to be a great source of information and heavy duty, high output parts. So that's good. But I'll put their email address across the bottom here. When you call, ask for Susan. She's the actually, she's probably the boss. That's the supposed boss's wife, but you know, we married guys know how this most often works. Again, can supply you with a good Lima cylinder head. And I think that's all I've got to say there. So really now it's time to get on with our flow test results. And I keep threatening this and I just don't seem to get around to it, but here it is for real. Here's the opening page of the IOP program. As you can see, we are offering a free trial period with this. All you have to do is keep pace with that link going across the screen. Just in case we overlook putting it below, I suggest you pause the video now and make a note of it. Why are we offering a free trial? Simple. We think this is the best program in the world. It's the only program which points you in the right direction for the next move. That's our claim. But we want you to see whether we meet that claim or not. So hence the free trial. Hitting the enter button on the title page takes you to our opening page. Here you provisionally enter a few things about your engine. First is the compression ratio, then the bore, stroke, and the number of cylinders. At that point we can leave the other entries until we have the data from the following pages. Button which says Flow Test 1 brings us to a page like this. Here we enter all the data that are in the white spaces shown here. This includes such things as what head it is, how many port cc's it's got, what the valve diameters are, what the size of the dimensions at the manifold face of the ports, the center line length, the port volume, etc. By collecting all this data, we can analyze in a much better manner what exactly is happening with the head and whether or not we've made an improvement. Here I've entered the flow test results for the head as received from either Ford or Esslinger, depending where it came from. Now you will see that on the intake, the peak flow occurred at about 600 lift, which was 215, but then it tailed off to 207. On the exhaust, it flowed pretty well with a result of 198 at 700. That's very compatible with a good Chevrolet exhaust port with a 1.6 valve. On the next slide, I'm going to show what we achieved by modifying the head. With 261 CFM at 700 lift, we're up quite a bit on the intake. However, the exhaust, not so much of a gain, up from 198 to 212. However, the exhaust was, in all fairness, pretty good to start with. But it's not these high lift numbers that we're so much interested in. It's what we do at the low lift that counts, especially on the exhaust. So let's take a look at some graphs here and see what we've got. The black arrow on the thin blue line indicates the results from the as received head. The thick blue line, arrowed, is where we got to. As you can see, considerable amount of difference. As for the exhaust, that's the red lines, you can see that our top end gains were okay, but nothing spectacular. What doesn't show up on this graph is the percentage gains at low lift on the exhaust, which was one of the factors that was our primary goal. So let's take a look at the discharge coefficients of these results here and see just how much the flow efficiency has gone up. Here we have the before and after intake flow efficiencies. The as received intake efficiency peaked at 65% at low lift. On the other hand, the modified one peaked at 88%, a big improvement. Now for the exhaust side of things. The as received head topped out at 67% as arrowed. On the other hand, after all the relieving we did in terms of shrouding, the modified port topped out at 83%, a very worthwhile improvement. With such an improvement, our initial blowdown should be far, far better than it was in the as received form. Apart from what I've already shown in graphic form, we did check out such things as port velocity, port energy, comparing the before and after, but I felt the video was getting too long and could well end up with too many graphs. Let me say that port velocities and port energy on the after one was slightly better, a few percent better than it was before. We also checked swirl. That was noticeably up. So all of those factors were, how shall I say, catered for during the modifications. They were in consideration throughout our modification process, and keeping them in mind and doing what it takes to get those things paid off. Not by a large amount, but it paid off. Now, okay, if I'm going to show some graphs, and I thought this would be a good comparison, is to take the Esslinger turbo modified head. That's the one that Esslinger do on the head, starting with the head that we started with, and it's their turbo one. We can see that we've achieved very, very similar results here. These tests were done by Bo at Bo's Porting in California, and it only shows the flow, no swirl or anything like that, but it's enough to show that we've progressed pretty well with what we've done. So let's just take a quick look at those, and then we'll talk about wrapping up this video. Intake first. Down at the low end, that's up to around about 100 thousandths or so, we have the Esslinger ported head beaten. I'll show the discharge coefficient so you can see how much we've beaten them by there. Mid-range, it's give and take some. At the top end, the Esslinger head flows better than our head. Now, if we go to the exhaust, bottom end, we flow much better than the Esslinger head. Again, the discharge figures will show that. And up at the top end, we flow better. Mid-range, we're about the same. Let's look at the discharge figures now. Our intake beats the Esslinger head up to about 1/8 of an inch lift. Then it drops below the Esslinger head by a few percent, and then picks up again at about 200 lift, all the way through the range until about 400 lift, maybe 450. It holds its own with the Esslinger head, but then right at the top end loses out slightly. But now let's look at the exhaust and see if we've met our goals there. And here we have the exhaust. You can see here that all the work we did on the 30-degree seat and relieving the chambers of shrouding everywhere possible resulted in a far greater flow efficiency at low lift. Exactly what we were searching for. Through the mid-range, they're not too much different, but once the lift gets to around about 350, our exhaust port takes off again and shows better results. Well, that's about it for this edition. Please don't forget to subscribe, like, get notified, and comment. All of that's a help for our channel. We're trying to make that magic 100,000 deal here for the MotorTech Features group. That's Unity Motorsports and PowerTec 10. We are close to it. It would be nice to have a little burst of subscribers so that we hit that 100,000 mark in the next, say, month. So please go for it. Thank you for watching. Oh, and by the way, we've got some more head videos coming. I've got one that I'm currently doing on small block Ford with some dart heads. I think you'll like what you see from the flow numbers and that is achieved. They are specifically intended to enhance the results you get from either a turbo, supercharger, or nitrous. If you are into any of those, you need to watch this video. And by the way, I will have the heads for sale after, because I'm focusing on my EcoBoost Mustang instead of small block Fords at the moment. Anyway, thank you for watching, and I will see you in the next edition of PowerTec 10.